everyone, today we're going to present this map of the house and all the electrical current that it has. Also, we're going to explain with the Ohm's law how the current works and how we can identify, for example, series circuits, and also how we can identify parallel circuits. So let's start.
Well, now we're going to explain to you the main plan of the house. Well, on here we can introduce that the pink lines represent the electrical rings, and the path that the electric current follows. As we can see here, here are the pink lines. Now, what can we take from here? The circles that we have on here are bulbs, and the small squares that we have on here are outlets. And the rectangle that it's on here represents a person using a TV, that as we can see on here. There is also some switches to control the lights, that as we can see on this part. Now, how this plan is structured? Well, the current enters from the main point that it's on here, from the entry of the house, and it travels through all the circuit. Now, when the switch is closed, the current can flow and the lights turn on. And when it's open, the current stops flowing like around.
Okay, and now I'm going to explain what are series connection and how are parallel connection different. So here we have the map of the house. Okay, so first I wanted to explain the concepts. Series means that the electricity goes like through all the lights, for example, and if one single light stops working, all the circuit also stop working. So there is just like only one way to a current to flow. And on parallel, the current have like many ways to get to the lights. So if, for example, one light stop working, the current will continue flowing. So here we have a perfect example of this. We can see how in the house, you can make it zoom. So we can see how in the house, all these lights are on parallel because there is not just one way for the electricity to get. You can see how it can expand to all lights. And if, for example, this light stop working, the rest won't stop working because it is just a single light and because it is a parallel connection. So this is the main difference. And now this is the time to explain the mathematics and how the Ohm's law work. So here we have our three examples for doing for the electricity that are in the house. So first we have the fridge. First we have to identify the variables. So we have V, that means voltage and is measured on volts. I, which means current and is measured on amperes. R, that is resistance and is measured on ohms. So here in the fridge the fridge has 110 volts and a resistance of 450. So to know the current, we have to apply this mathematical equation. I equal to V under R. So we have 110 divided in 450, that is the resistance, and we have 0.2 amperes. Now the TV. The TV we know that has on 0.83 volts, and also it has 50 of resistance. That means ohms. So the formula that we're using in this case is multiplying 0.83 by 50, and this is the result, that is 41.5 volts. Okay, here I make a mistake, and in this case of the TV we're not looking the current in the case of the fridge. we're looking for the volts. We have already these two variables, that is the current, and we have the variable that is the resistance. So the formula also change. We're not looking the I, we're looking the V. So the formula is multiplying the I that is 0.83 multiplied by the R, that is 50, and this gives us 41.5 volts. So this is the case of the TV. Finally, lights. In this case, we're looking the R, the ohms. We have these two variables, that is the V, that is 230 volts, and the I, that is 9.5 amperes. So we have to divide this, that is 220 and 30 divided by 9.5, and this gives us 24.2 ohms. So this is how the Ohm's law work, and in mathematics you can say it like this.
Now, something that we have to have present is that the current over the time is not always the same. When the electric current, the electric current change over the time, because when a device starts to be on, this electric current starts to going up from zero and increases until it becomes stable. It can be represented on a graph with our devices. Having an example on this, we can have located the fridge. Well, the fridge have a similar system when the current change, because its motor gets on, and it turns on and turns off. So while the light bulb current stays constant as long as it's on.
Okay, so in conclusion of this video, we can say a lot of things. First, that understanding the difference between series circuits and parallel circuits, we can know which one is most efficient efficient than the other, and why it's better to have on ohms, for example, parallel circuits than series circuits. Second, now with this Ohm's law, we can understand how electrodomestics and how electricity on home has this voltage, has currents, and how to find the resistance. So it's important. And also we can see how electricity works on our homes, and how the light, when we press the button, it turn on and everything. So I think that it was like a productive Ohm's law video. Thank you.